All right, welcome back to the final. Let's make sure sound is working, and it is. The final recorded lecture for the Linux series here, and we're going to go over TLS and SSL. In particular, we're going to have an example with a web server using Node.js in Linux, just to demonstrate that we can do it. So, first thing we got to do is go over what TLS and SSL are, and then why we use them. Okay, so cryptography. It's a method of obscuring data. Everyone else you're going to talk to is going to call it securing data. The reason why I want to focus on calling it obscuring data is because most of our encryption algorithms have been cracked already, so it is just kind of an annoyance for the most part. If someone gets a hold of cryptographic data. However, if you're talking to a business professional, a client, something along those lines, they're not going to want to hear obscuring data because they don't necessarily know what that means. They're going to want to hear it's secure. All right, so for the most part, save yourself some trouble and just call it secured data, even though that AES 256 will be cracked eventually, particularly if quantum computing starts to become a thing. Okay, so with that said, the process of cryptography is essentially encrypting and decrypting data. So data at rest is going to be encrypted. Data that is being actively used is decrypted. This is part of the reason why man-in-the-middle attacks are so effective, because you can get unencrypted data depending on how you're transferring that data in motion. Okay, encrypted data is also known as ciphertext, where it's just a series of essentially garble to us, but there is a pattern. It's just generated by an algorithm, and there are two types of encryptions. There's symmetric and then asymmetric, which we're going to get into right now. Symmetric, okay, so this is what we used for a long time. It's a single key. Encrypts and decrypts, all parties require that key. That single key must be secured. If that key is ever compromised, lost, altered in any way, all that data that you had encrypted is now officially compromised. And this is the biggest downfall with symmetric cryptography. It's very difficult to secure a single key, and it's even worse when most of the time, most of your problems comes from the person, right? Social engineering is your best vector. So easily could be the scenario where you talk to the one person that's not very aware and gets social engineered. Oh yeah, here's the key. And now they have the key to everything, okay? So algorithms, AES, RC4, 3DES, and Blowfish. Those are your common ones. We use AES for the most part. 3DES is used occasionally. I've seen it a couple times, but AES is the standard for the most part. Okay? Asymmetric cryptography. It is a mathematically related key set. So you have a private key, and then you have a public key. The public key is what you give out. The private key is what you keep. I don't know how else to make that more simple or more self-explanatory, okay? Algorithms are very much the same. Some of them are different, but for the most part, you're going to be using AES. So where are keys stored? As far as web developers go, or programmers in general, these are going to be on the server, some sort of file, some sort of token. If we're talking in the real world, in the physical world, well, that could be just about anything, right? That can be a smart card or a CAT card like I had in the military. That can be a token device like a fob. That can be a TPM module like Apple's been doing lately, or what Windows is trying to push for with their Windows 11, where, hey, you need this TPM module on your device. So it's, in theory, more secure, all right? What is a PKI? It stands for Public Key Infrastructure and allows for storing of public keys. Okay, so we won't be doing a PKI in this course. If you're in my Windows admin course, we'll be doing a PKI environment there. It's going to be a little bit on the superficial side where, okay, yeah, we set it up, but we won't hand out any keys. Just because we don't have, we have one client. It doesn't work very well. Okay, so PKI components. This is one of those things where you don't necessarily need to memorize it, but it is something if you're trying to create a PKI environment for yourself, which you don't do very often. Most of the time it's set up for you. You're going to have to read and figure out what these things are. So a CA, Certificate Authority, issues, renews, and revokes keys. So this is going to be a entity that's already trusted. So Microsoft jumps to mind. They are a certificate authority. If Microsoft gives you a certificate, Microsoft is essentially saying that yes, you at this domain, you do exist. You pass our standards, okay? And here's a certificate stating that you are an entity that you say you are, okay? Registered authority is a subordinate of the CA. Think of it as the CA that you have, that is essentially controls you, right? Generally speaking, you don't contact the CA directly. That is a lengthy process. The registered authority essentially manages the certificates that you already have that was given by the CA. Okay, certificate revocation list, verification of certificate of validity. Okay, online certificate status protocol. It's a different protocol. It's the protocol itself to do certificate validity. Okay, certification template, a blueprint when issuing certificates. Okay, also self-explanatory. Hey, we have a secure web server. You're a client for that secure web server. We're going to use that same template over and over and over and over and over again. Okay, that type of stuff. Then the certificate itself, the content that is in there is going to be your subject name, signature of the CA, expiration, and then public and private key info. Mostly where to find it. Okay, TLS and SSL. So this is pretty important. So most of the people, actually let's back up. SSL was ubiquitous 10 years ago. And then Heartbleed happened. Once that happened, everyone started changing over to TLS, all right? Now, the problem with that is that with human psychology, they tend to, and by they, I mean people that have already learned something, they tend to associate something new that is similar to that new thing with the old thing that they already knew. So TLS and SSL are very similar. Most people call TLS SSL, and it is technically wrong. However, you need to be aware of that. And even we're going to be installing a package today that is called OpenSSL, and we're going to get a TLS certificate. Right? So that is a problem, and this is a human psychology problem, even down to when governments introduce new coins that are too similar to the ones that they already have, people get upset, right? This is a human problem, not necessarily just this. But back on track, SSL is deprecated, essentially, okay? You want to be using TLS. All modern browsers support TLS 1.2. 1.3 is relatively new at the time of this recording, but give it a little time, probably about a year, and then your modern browsers are going to have support for TLS 1.3. And again, I cannot stress enough that most of the things that you're going to use, they're going to call it SSL. You're getting a TLS certificate and an encrypted key, all right? So this is where we're going to go through. Now, there's no way you're going to be able to memorize these very long commands, okay? That's what's coming up. But use this as a reference for when you're going to need it in the future. So we're going to install OpenSSL packet. All right. Going to create the CA. Now, this is our own CA. This is not Microsoft, right? So this is essentially self-signing our own certificate, which is going to come up as insecure, which I'll show you here in a second. But it does encrypt our traffic, which is what we're going for. Okay. Root certificate. Open SSL. Server out key. Okay. Server key, server out. So this is creating your CSR. Okay. And then create the server certificate. And then we're going to load in those keys. Now I'm going to use Node.js. Apache was giving me problems when I was doing this earlier, but it doesn't really matter what type of language or server that you use. You just need to use one. And then you're going to get something like this. So HTTPS, localhost, on a different port if you're using Linux, because you do not have permissions to use any of the lower end ports. I think it's 1024. Anything lower than 1024 you're not going to have access to. So you can't use port 443, which is typically your HTTPS protocol. You're going to have to pick a different one. All right, so here's your warning stating that, hey, this is a self-signed certificate, but it still encrypts your data. Okay, so with that said, I'm going to have to pull this down to use it myself because I don't have these memorized by any means. Okay, so what we're going to have to do is open this up. Plus, plus, and plus. Okay, so there's that. We're going to have to install OpenSSL. Come on, give me the confirmation. It's done. It's done. There it is. Okay, we're going to create the CA now. $256. Okay, so encryption algorithm right here. Out, which is going to be the name of our key, and then the bit. Enter. Enter passphrase for root key. And what this is doing is essentially going, hey, if you want to access this key, you need to know the super secret password to access this key. So most of the time, if you're going to be in an environment like this and creating keys, you're probably the lead network admin. So this is probably going to be you, and then whenever you leave that company, you're going to have to pass off that information to whoever's replacing you. All right, moving on. Open SSL rack X509. I have forgot what 509 does. Root ca.key SHA 256. So this is your hashing algorithm. If anything changes on this, your checksum is going to be different. So yeah, if it's different, don't use it. That means it's been altered. We're going to set this to 365. So we're creating this for a year for duration. Typically, this would be a lot longer. Enter root CA key. Okay, US. You typically don't have to enter all this information, but it's helpful. So there is that. So this information would end up going to the CA, so Microsoft essentially. So if they had a problem, they could contact whoever was in this. Open SSL gen RSA. Okay, creating the server key now, same bit. Awesome, awesome. Open SSL rec. New key server key out server.csr. And we need a space here. Same thing here. Nah, not New York. It's fine. Organizational name, organizational unit, CIT, common name, localhost. Challenge password. No, I don't want a challenge password. There we go. There is that. All right, now we're going to create the signed certificate for the server. So this is a long one. X509 rec in server.csr CA key root CA key CA create serial out CRT day plural 365 SHA 256. Okay, enter the passphrase for the root key, so we're trying to use the key. Now we need that super secret password. So there's that. And let's see what we got. So one of the problems that I had, and I didn't think about it until now, is that all of our keys are right in this home directory. I generally want to be a little bit more precise than this. So what I'm going to do is I'm going to make a directory. I'm going to call it web server. All right. And then I'm going to move. Actually, I'm just going to use the GUI. It's going to be a little easier. So here's this. I'm going to open up web server, new window. Here we go. So I need this one, this one, this one, this one, this one, this one, over. We're going to make a new folder here. We're going to call it keys. Okay, so this is where we got to get our new web server to this folder. So first thing we got to do is we got to install Node.js. Now, I am not sure. Oh, not span. Snap. I'm pretty sure I already have Snap installed on this. So, with that said, I'm going to install Node.js using Snap. So, sudo snap install node. I think it's just node. Okay, I need classic. All right, now I'm going to change directory. I'm going to go into that web server folder. All right, so our folder of keys is still here. Now I'm going to run npm init, and hopefully that's going to still be installed. Nope, apparently not. So sudo oh no, web server. This is working. Okay, good. So let's call this TLS server. TLS server. Version 1 is fine. Description, TLS examples server. Entry point. Sure, we can do index. Test command of test. Get repository, don't have one. Keywords, don't care. Author. License, don't have one. If we were going to make this public, we'd probably use that MIT license. Is this okay? Sure. A new minor version is available of NPM. Okay, great. All right, so now at this point, I'm going to ls this web server, and we have package JSON. I was expecting significantly more. So I'm going to run npm install now, and this should give us everything else that we were looking for. Package lock. All right, well, there is that. So right now I'm questioning Homebrick Shade. So this should have gave us a entry point of index.js. Interesting. Anywho, let's go ahead and pull up that example I did some time ago. State courses, Linux scripting. Samba. I want this. Okay, package JSON. I don't have any dependencies.
Hello, design. Have a great day.
Okay, so what I'm doing here is I'm recreating this server file. I don't think I need that. Where is this? And then once I get there, then it'll work. But it's going to take a second. Nope. And to be clear, guys, I don't have this memorized. I am definitely using a reference. We weren't looking for fstat. Okay. Give me a second to fix that. That's going to be an express module. Morum. You look at the thermometer today.
I sure got chilly in it. I thought you were putting your coat on like you're gonna go somewhere.
Oh, no. If you're going outside, I would layer. Is there any wind?
No, it's pretty calm.
Yeah, well,
Yeah, these cold mornings, I do the double sweater thing,
yeah.
and then the jacket. It's toasty warm, you know, except for my hands, of course.
Yeah. Yeah, I walked in the bathroom to take a shower this morning, and you know that window's always been drafty.
It's always been a cold son of a bitch, yeah.
Yeah. And I walked in there, it's like, it's legitimately cold in here. Like, legitimately cold.
Yeah, kind of shut the door. They're kind of cold in there, you know.
Yeah.
I
So,
had that goddamn thing back. You know what it needs is replacement.
I mean, I can break it again for you if you want.
What's that?
I can break it again for you if you want.
No, I wouldn't. This would not be a good time of year for that. But
No, it would not. But we can get a couple golf balls out.
yeah, we know a golf ball will do it, won't we?
Yeah, that we will.
Don't we?
Yeah.
Yeah, yeah. And it's gotten just a tad bit colder now that day is breaking.
Well, the one downstairs said negative 15 when I got up.
Oh yeah.
Yeah.
So these up here.
And this wind chill says negative 24. So,
Whoa. At some point, huh? I don't know it right now.
I think this is right now. Negative 24 with wind at 4 miles per hour.
Don't take much, does it?
Now, when is this cold? And this thermometer went down. It was 66 in here.
I don't know how these deer and things, you know, survive. They do, obviously. They just hunker down.
I guess.
But man,
Yeah, I don't know. Humans did it too for a long time.
oh,
So.
yeah.
But with that said, that doesn't mean that a lot didn't survive the winter either. So days like this, there's probably people that didn't make it just because it's cold.
Yeah. I mean, the American Indians, they've managed to survive. The Native Americans, I should say.
Okay, so that took a little while to get up and running. So let's go over the code real quick just to make sure that you guys can get this up and running. So if you were following along up to this point, you had Node installed. We did have to install in Express just to get app going here. I could have done it without it, but it's a little bit easier for you guys because this isn't a web development course. Okay, so we needed file system, HTTPS, okay, then Express, make app from Express, and then we're going to set our port. Then we're going to create our server here, our certificate. We're going to read in that certificate key, or the certificate key. We're going to read in that key, and then CA, that self-signed certificate. We're going to read that in as well. Then we're going to run the server. We're going to come over here. We're going to go to localhost and then whatever port number this is. So, yikes. Sure. So, HTTPS, localhost. I set mine to 5353. Warning. Okay, so this is working. Oh, wrong thing. Advanced. Someone could be trying to impersonate this site and you should not continue. Basically what this is saying, here's the certificate. I self-signed this certificate. This is what this is saying. So New York, which is the mistake that I had earlier. So issuer name, US New York, Alfred State, okay. This is the certificate that we had. So with that said, that is up and running. That also means that our network traffic between this web server is encrypted. So with that said, that's going to end this lecture, and it's also going to end the series as well. So if you watched all those videos, well, good on you. I highly doubt that anyone will. However, use these lectures and these recordings as tools, as references. If you're an Alfred State student, you will have access to the PowerPoints themselves, so you don't necessarily have to watch the video. But this is a tool just in case you guys struggle. So with that said, that's going to be the last one. Thanks for sticking with me.